Greetings, this is Chemistry with Nav. In this short video, I want to show you the small difference between the electrophilic addition of hydrogen halides, for instance HBr, and halogens like Br2 with alkenes. So both of them go through an electrophilic addition mechanism, but for any mechanism in organic chemistry there needs to be a reason for it to start. And with the hydrogen halide, you have a polar bond, a delta plus, delta minus across that HBr bond because the halogen is more electronegative and so it pulls electron density towards itself in the covalent bond. That means that the electron-rich carbon-carbon double bond has something to aim for. We can move those two electrons now out to the hydrogen, and then we get this electron cascade, as it were, with the HBr bond now breaking, moving its electrons there onto the bromine. And that gives us this next step where in fact we have a carbocation, but also that hydrogen has attached itself now to the structure. But the electrons moving onto the bromine atom has formed a bromide ion. That bromide ion can move its electrons onto the electron deficient carbon, which means that we end up forming our bromoethane, like so. So fairly straightforward, and a simple reason as to why that mechanism does start. However, with the Br2 we see something just slightly different, because if we want that mechanism to start and to behave in exactly the same way, then we need to have a polar molecule, but we know that Br2 is not polar. So where does that dipole come from? Well, we get something called an induced dipole, and as the bromine molecule approaches the alkene, the electrons in the bond are actually pushed away from the nearest bromine. So in other words, that closest bromine becomes slightly positive and the furthest bromine becomes slightly negative. So that's where the dipole comes from. And as a result, we end up with pretty much exactly the same mechanism. I'm not showing my hydrogens here, being a bit lazy. So we have a bromine that's already attached, and we also have a bromide ion again waiting to attack that carbon, and this time we get the 1,2 dibromoethane. So that's the major difference, the fact that the Br2 needs to have an induced dipole. And if you're doing A2 chemistry, then you would have come across this in the context of bromines with alkene and also bromine with benzene. The benzene doesn't have electron density strong enough in order to induce a dipole in bromine, whereas alkenes do. So that's why benzene needs a halogen carrier in order for that reaction to occur.